Okay, hello everybody. So today we're going to continue our discussion on solving systems of linear equations, but we are going to learn a new technique today, and that technique is called elimination. Um, this is very similar to substitution in that it is an algebraic way of solving systems. However, the actual technique is slightly different, which I will show you in a second. Here's a little bit of vocabulary for you. Remember, whenever we solve systems of linear equations, there's actually three different outcomes that can happen. If I were to draw a quick example, we could have a system where the two lines simply intersect at a point like this, and that system would have one solution. And as we say, that system is called independent. So an independent system is a system that has one solution. The next outcome that you could have whenever you are solving these systems is you could have infinite number of solutions. Now, infinite number of solutions is whenever you graph a line and then you go to graph the second line and they're exactly the same line. They're right on top of each other. What that means is they share all of their points. So there's an infinite number of solutions. If that is the case, the system is said to be a dependent system. Now, the last thing that can happen whenever you solve a system of two linear equations is that those two lines could be parallel and not intersect at all. Now, if you have that happen, there will not be a solution because they do not intersect. And that system is called an inconsistent system. An inconsistent system has no solution. Please also remember what happens algebraically for each of these. For an independent system that has one solution, you will end up with an ordered pair, an x and a y, in your course of solving. In the second example, for a dependent, you will end up in a situation where all of the variables will cancel away, and you'll be just left with a true statement like 2 equals 2. In the third example, where the two lines are parallel and they do not intersect, you will end up with, similar to the last example where all the variables go away, but you will end up having a false statement, maybe something such as like 2 equals 5 or negative 3 equals 7. In that case, where all the variables go away and you're left with a false statement, that means there will not be a solution to that system because the lines don't intersect. So let me show you how to solve this. So we have studied now, I believe, 3 different ways to solve these systems. We can either solve them by graphing, which is just plotting points and drawing lines and figuring out where they intersect. We have studied how to do substitution in the last section. And now in this section, I'm going to show you how to use what is called elimination. These two techniques are an algebraic way of doing that because we use algebra instead of graphing. So this is solved by elimination. And as the name indicates, the goal here is to eliminate something. Now, what we want to do is we want to eliminate one or the other variable. Either we want to eliminate the x or we want to eliminate the y. It just really depends on the problem as to which one we eliminate first. It doesn't really matter because once you've solved for one of the variables, you will solve for the other variable after you solve for the first one. So it doesn't matter which one you solve for first. Now, some key things to look for is you want to look for numbers that are the same except for they have the opposite sign. Now, what that means is because that's a positive 6 and a negative 6, if I were to add those two together, I would get 0, and 0 will cancel out anything. So what we're going to do is we are going to add these two. So you can see both of these equations are already in standard form, which makes it really easy to use elimination. I'm going to add these just like we learned old school addition. So we're going to add 4x plus 3x, and that equals 7x. Then I'm going to add 6y plus negative 6y, which gives me 0y. And then lastly, 32 plus 3 is 35. And what you can see, 0y goes away. We don't even need to write 0. It's gone. We're just left with 7x equals 35. Well, that's pretty simple to solve for now because we only have one variable. All we need to do is divide by 7 on both sides and we get x equals 5. And so now we have one of the two numbers that we need. We have an x, now we need to get our y. How you get your y is really kind of up to you. You can substitute it into the first equation or the second equation. It doesn't really matter. I tend to look at which one has maybe a little bit smaller numbers. In this case, the second one has the smaller numbers. So I'm going to go ahead and use that. So it would be 3 and then x minus 6y equals 3. In place of the x, I'm going to write a 5, and then I'm going to follow PEMDAS to simplify that. I'm actually not going to follow PEMDAS. I'm sorry, I misspoke. I'm going to solve for the y variable. So this is going to be 15 minus 6y equals 3. I'm going to subtract 15 from both sides. I get negative 6y is equal to negative 12. And then when I divide both sides by negative 6, I get y equals 2. So you can see I got an x value, I substituted that back in, and then got my y value. And so the ordered pair, remember, once you get your x and your y, I do ask that you write the two numbers for the ordered pair. And the ordered pair is 5, 2. Now, what does that point mean? Well, that point means if you were to graph both of those equations, you would see that those two lines would cross at the point 5, 2. So let's try another one. So same thing. We have two equations. They are both in standard form. And we want to eliminate one of the variables to solve for the other variable. So looking at this system, you can see the x ones are going to be the ones that are the same number, but one is a negative and one is a positive. So what that means then is if I do add those up, they will eliminate. So we have negative 3x plus 3x, and that's 0. Then I have 4y plus negative 6y, which is negative 2y, equals 30. Once I have that, I'm going to divide by negative 2 on both sides, and I get y equals negative 15. So there's our y value. Now remember, if you remember in the last problem, I said it doesn't matter which variable you solve for first, because once you've solved for one of the variables, you're going to plug that value back in and solve for the other one. So I'm going to go ahead and use the first equation this time. So we have negative 3x. Now remember, that negative 15, that has to go in for where the y value was, not the x value, because negative 15 is y. So notice I put it right into here, substituted negative 15 in for y. Now, once I've done that, I'm going to go ahead and solve for x. The first step is going to be to multiply 4 times negative 15, which is negative 60. Then I'm going to add 60 to both sides. Once I do that, I have negative 3x equals 72. And then I'm going to divide both sides by negative 3. And I'm going to get negative 2, 4. So x is, whoops, my screen is blocking that out. X is negative 24. So the last thing then to do is to write your ordered pair. Negative 24, comma, negative 15. All right, guys, that's what I have for you today. I hope that made sense. We're going to have a couple more videos on this section as this can get a little bit harder. So if you have any questions, feel free to email me. Have a great day.